So first things to know about starting over. The first thing to know about the final exam is when it is. It's going to be May 6th. We actually have, so you guys are section 90, and right here this is your time slot, and the final exam is online. Now, in terms of finding the final exam, I'm going to share our Canvas website with you guys. So our Canvas page right here. There are several ways where you can get there. You can go through tests, or you can go to daily information, or jump straight to modules if you're in your phone or on your phone. Hopefully you're not in your phone. So I put all the information about the final exam right here. It looks format-wise very, very similar to what you guys had for test 2. So it talks about making sure you have this all set up. At this point, since I believe everybody took test 2, you should be all set as long as you use the same device. Practice exam for the final exam is coming. It's not done yet. Once it is up and ready, this will turn into a link right there. If you do find any issues, let me know. Hopefully there won't be any. What I'll do when we get close to the final exam, it'll probably actually be Wednesday, is I'll flip-flop this part here that says practice final with this one here that says actual final exam. In terms of finding your final exam, it's not here yet, but there'll be a button, some obnoxiously brightly colored button similar to what you had for test 2 that says something along the lines of final exam, or maybe just final. Probably it'll say, or maybe just exam, I don't know. It'll be something. Yes, we are recording right now. This here, the page, is not fully done. You will notice there are a couple of missing pieces, like for example, right here, I still have to go and do a little math to put the window or when this test is available centered around your exam time. And in terms of how long you'll have to complete each attempt, you have 2 attempts and 3 hours to complete each attempt. Okay? Second attempt is mainly just so if you have any sort of technological issues and get booted out of your first attempt, that's okay. You can still take it, and we don't have any major catastrophes that we have to worry about. If you want to actually take 2 3-hour final exams back to back, I wouldn't recommend it, but yes, so point of clarification. In terms of your attempt, I will give you the 3 hours. And how that'll be centered is it'll be centered, you could start 15 minutes before our original start time and end basically 15 minutes after the original start time. So in other words, those 15 minutes that normally you would be walking between exams, you can totally go ahead and just grab them. Although technically, we're the last exam in the slot, so it might be easier just to do the windows like 8 to 11 type thing. So just like with test 2, where you guys actually had a little bit longer than actual class time to go ahead and take it, same deal here, but I'm centering it or putting the time slot of when you can take your attempts on our final exam so it won't interfere with other final exams. Okay? That way, assuming you guys have more than one final exam, there's no issues in that sense. That's the main thing with those guys. Yes, so each attempt will be timed. So just like last time when you had like an hour and something or 2 hours, I can't remember what the time was for test 2, and it would cut you off after so long. Here, that so long is 3 hours, and if you want 2 attempts, you can have them. And this is why I have to do some more math than my head was capable of last night at like 3 a.m. to figure out when your time window will start and stop. But yes, you are correct. Literally just said I don't have that window yet. It is coming. So you'll see this change when it comes. Okay. In terms of things to know, this is the same stuff that you had from test 2 in terms of writing stuff in. This is only applicable in some sort of free response bullet point or in the proofwriting guides. In terms of questions, you can totally ask me questions during the test, but so far the only way we've been able to make that work is if you log into the WebEx session before you try to take your attempt. Okay? So if you go straight to taking the test, that's totally fine, but in that case, you'd only be able to talk to me between attempts if you decide to do a second attempt. Okay? But anyway, buttons here was the main point. Anyway, we've talked probably more than we need to about that, so let's jump back to the actual study guide. And this is right now live on Canvas, so you'll be able to go through all of that information at your own pace as well. And I'll most likely shoot you guys a announcement through Canvas about when the practice test is up, and by that point I should have all of those missing pieces up on this information about the final exam as well, such as the start and stop window. Where were we? Right. So total 3 hours for each attempt, 2 attempts. I would not recommend trying to take the 2 attempts, but you can if you want to. In terms of the test, there are 3 things to watch out for. One of them is the main test itself. So here, let me go ahead and highlight this. It's going to look really similar to test 2. You can see all sorts of questions. Maybe you have 3 response questions. That might be similar to like what you guys had on the first 2 questions for test 2, where you were asked about a definition, you were asked to explain the difference between 2 things. You may have something similar to that again. Okay. Multiple choice questions, maybe there's something that says, hey, which of these is the best thing to do? Probably won't get too many of those, but it's likely that you might get 1 or 2. Fill in the blank questions. This would be similar to test 2, like when you were asked to show if an axiom worked or didn't work in a specific model. So these are the ones with the fill in the blank ones where you want to watch out for some of those extra directions where what do you want, what should you be entering and how in these different blanks. And maybe you have something like a matching problem where you have, that might be a way to do a proof question where you literally sort of line them up of what things go where. Maybe not. I haven't figured out how to do matching very well yet with our topics. Something that didn't make it on here, but what you guys saw on test 2 that's highly likely to be a type of question format for final exam is something like the finite geometries, where you had all of those pictures of all the different geometry configurations, and it asked you questions like, is this an incidence geometry? And there was a drop down of yes, no. Those type of things you may see again where you have various questions and you've got a drop down where you get to select and essentially fill in the blank, but I've already pre-formatted the answers for you so you don't have to worry about did I type it in perfectly. I find that's actually really helpful when we can have converted from paper to online for all of my classes actually. Now here's something that is highly likely to occur. I am not going to guarantee that it's going to occur right here, but there may be one question, and it's likely that that guy will either be a proof question or a construction question. So specifically there on those ones that are really difficult to put it into some online format where you fill in the blank or even rearrange a scrambled order of stuff, this would be something where you could write it out on your own piece of paper or type it up, and then you would upload that file. Now, not 100% that this is going to happen because I still got to figure out which, if any of the questions would do this, but be aware that this may very well be something that you need to worry about. If this happens, back in the page on Canvas where we had, or we will have the buttons for the final exam, this is now shared in the second window. You've got the big button right now that says scratch work that isn't working. And then here is where our button for our final exam will come once it's up. There would, in this case, if there's a file upload question, it would be a third place for you to upload something. So you'd have like a part 1 of the test, which is the main part of the test, and then part 2 would be the file upload. You would have to do that after you finish the first part of the test and essentially log out of the Respondus system, because you can't upload a file through Respondus. We have tested that several times and just cannot get it to work. So that's the thing that could definitely happen. Third thing to watch out for is there will be a place where you can upload your scratch work. Please, 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 if you want to upload your scratch work, make sure you put it there. Do not email it to me. Okay? But those would be the 3 big things to watch out for in terms of the actual test itself. Okay? Now, on to the topics. Okay? So what I did that was different on this study guide than the previous study guides is the whole first page is just dealing with the online part. Okay? So topics. This test is, roughly speaking, a third test. Okay? Most of the test is very much like a third test. So we are looking at, in terms of our sections, these are all of the sections from test 2. So this first part right here, sections 13 through 16, this is chapter 3. That's dealing with Cartesian planes configurations. Sections 19 through 25, we're dealing with similar triangles, area dissections. And then this section here, 28, that was the algebra section that we had just a little bit of with having constructible numbers. And then 34 is the one with the non-Euclidean geometry. Okay. Now, in terms of types of questions that you could have, there are roughly 3 types of questions. The first one is, roughly speaking, something that I'm going to call topics questions because I don't have a better name for it. And this I'm going to break down specifically on the next page. Okay? So these guys are going to be really, really similar. I actually give examples of what you could see on that next page. This number here that normally would be the number of questions, that would be applicable if we were a paper test. In terms of an online test, how the questions have been working better is to break them up into sub-pieces. So where on a paper test you might have one overarching question and it asks you like a part A, a part B to walk you through it. In the online version, it's been easier to actually break those up into 2 much smaller questions. So this here, roughly, that's not super applicable. But it does give you scale-wise roughly what would happen. The other type of thing is proof questions. This is accurate. You'll have 1 to 2 proof questions from the new material. And those guys will be pulled exactly from the list that's on the next page, or close enough that if you know how to deal with those guys on the next page, you'll be perfectly fine. Okay? Just like before, I will give you guys a list of the propositions. It will most likely be a PDF that you would want to print out, download something beforehand, or it's possible, as a couple of you have suggested in the past, that I might do abbreviated versions of that list of propositions actually inside some of your different questions. So you could see either or both. And standard thing with proofs, don't forget to cite everything. And if you didn't use some proposition from your list of propositions, don't worry about it. It's a stock one for all the different types of questions that are out there. They don't make a different one for the different sections. The other thing is, in terms of old material, there will also be 1 to 2 questions from the past material that we have. Now, if this was a paper test, here's how it would go. There would be 7 questions or 7 pages. There might be subparts on a question. 1 question would be from test 1, 1 question would be from test 2, and the other 5 questions would be a test 3. So exactly the same length as our normal test. And I would tell you guys that you get exactly 1 question from whatever you had for test 1 and exactly 1 question from whatever questions you had from test 2. Unfortunately, I can't do that this time because for test 2, we had question banks. And you guys got randomly selected questions for a number of the different slots. So I can't tell you, hey, this one's coming directly from test 2. So I've changed that up, and here's how this is changed up. In terms of test 1, you're likely to either get a construction question or some sort of theory question. And when I say theory question, that would be similar to the first 2 questions you had on test 2, where you had to write something. It asked you about something, or like the first page of test 1, where it said, hey, give this definition, give me some sort of example of what's going on here. Okay. In terms of a construction question, this would be like a file upload question where it might legitimately ask you, hey, do the construction of blank. Okay? And it would, if it's a test 1 topic, that would be a classical Euclidean construction, straight edge compass on a piece of paper type thing. In terms of how to study for that, I'm not going to give you anything super crazy, off the wall complicated. As long as you know your definitions and how to deal with things, you'll be able to put something together. So for example, suppose it was something like construct a square. Don't overthink it. You have to know what the definition of a square is in order to get to the answer here. But as long as you can construct either perpendicular lines or parallel lines, and you can copy a line, you can deal with the construction of a square even if you didn't prep out for it ahead of time. Okay? So those are the type of things that I'd be looking for in terms of from test 1 type stuff. From test 2 type material, again, it could be a theory question. You guys had samples of theory questions. This first 2 questions from test 2. And it's likely that this guy might actually be some sort of model question. Why? Because it's easier to deal with than a proof question. So if there was something, a model type question, this would be similar to those questions you had in the middle of test 2. So that would be something like maybe you have a finite geometry and you're asked, hey, is this guy an incidence geometry? Maybe you're asked to verify an axiom holds in a certain model. So those would be the type of questions that you might see come back as review. But by far, the majority of this is definitely a test 3. So that would be the idea there. And then this bullet point here gives some of the main things of don't forget these guys. Test 2, in terms of the settings, I don't know if you guys can see it right now or not. I switched the settings so you guys should be able to see both what you answered and which ones were right or wrong. But I'm not sure if you guys can actually view it or not at the current moment in time. I couldn't get that test to check, and I don't have a student view that fully works. So if you guys cannot see your test 2, somebody send me an email, and I'll go and work on the settings so you guys can actually see your test 2 questions. All right, and the last thing to look at is the specific topic questions. So these are the different areas that we've actually covered. And at the bottom that you can't see yet deals with the proofs or the sample proofs to look at over. So first thing is, and these are almost in order of when we looked at them, first thing is dealing with configurations. So if you had a question that was a configuration question, this guy would literally be given the picture, that configuration that looks like lines and points all put together in various ways, and you would be asked things like, hey, is this configuration possible? So this would be similar to, oh dear, I don't remember which homework number this was. Whichever homework was associated with section 14, where you had a bunch of different pictures and you were asked, hey, let me find the points, let me find the equations of the lines, let me find now the slope of a specific line in 2 different ways, let me set those 2 different expressions for my same slope equal to each other, let me solve for A. Okay? And it would have to walk you through that sort of procedure. So that would be the idea there. So if you want to look at some of these different examples, here are some of the classic configuration examples, and you can look over those guys. The second topic that we looked at was area, and I went ahead and put similar triangles in here with area. Section 20 right there is similar triangles. 22 and 23 are dealing more with area. So this one here is key things. You want to be able to find the area of a figure. The only formula that we actually have is the area of a triangle. So in terms of finding the area of other things, you're looking to build it by way of, honestly, by way of dissections. You cut up the figure in a bunch of little pieces, and then you add the little pieces together. Now, specifically in terms of this section, if you're given one of the questions, the big examples to look at are exercises 23.3, 23.4, and the one that was very similar but shorter than 23.3, which was our in-class example that we had. This is the one that looked like a triangle with lines on the inside. And the key thing was we used Menelaus' theorem. So make sure you can use Menelaus' theorem. And then we also use that trick where if you have 2 triangles with the same height but different bases, their area is going to be the ratio of what the bases are. Or you can find the area by using the ratio of the bases. And if you've forgotten what we did when we did that, it's both posted on Canvas, the couple of things that we did in the past. That would have been in this section on area. And I also had a pre-recorded video from a previous semester that talks about how to use that, the notion of 2 triangles that share a height and their bases are different lengths. It goes into it a little bit more in depth than what we did in class. I've been pronouncing it Menelaus. I think you've got an extra syllable in there, but yeah, basically. So that's basically in terms of area. The big one in terms of area is make sure you can find the area of some middle sector or corner sector or one of the triangle sectors of somebody similar to what you, what is it, area? Was that the last homework or was that in this homework? I think it was actually this homework set where you had that triangle and you're trying to show that one of the pieces was 1/7 the total area. Something that I'll often do if I give a question that's similar to that would be, for extra credit, can you find the areas of the other pieces and parts? I mean, once you find one of them, it's the same process to find all the other pieces. All right, so that deals with area. The next thing we talked about was dissections. So there's a couple of different ways that you can see dissections, and these guys right here with dissections, I have to admit, are the ones that might is the key word here, be the hardest one to convert to online. So I've been thinking of a couple different ways to do it, and one of them is by far the easiest way to do it, and that's making sure you can apply theorem 24.7. Now, I don't care if you remember the number of that theorem, but 24.7 says a dissection exists if and only if the two figures have the same area. So you might have a question where you're given two figures and you're asked, hey, don't find the dissection, but does a dissection exist between those two figures? And the answer would be yes or no. In other words, that's exactly the same type of question that you had in leading parts on the quiz attached to last homework. So that's something that you could totally see. Something else you could see is maybe something similar to like the homework question you guys were asking at the beginning, where you're given two pictures, and maybe you're asked, hey, does that dissection actually work? Is this not an optical illusion, but is this a true dissection? And so that might be something that you would be given. It probably wouldn't be as in-depth as the one that you had for homework because you'll see it much quicker, unless it is exactly that same guy. The next bullet point under dissections talk about being able to do the 3 steps of the dissection, brainstorming ahead of time, doing the actual Hilbert construction and the proof. I don't have a good way for you guys to actually do all of those pieces and parts and input it specifically into Canvas. However, again, we can go and grab individual pieces and parts. So if we go a little bit more in depth than what we just talked about of does a dissection exist or not, maybe there's a step further where somebody says, hey, we think this dissection exists, and here's the two pictures all cut up into pieces. You show that this piece 1 from the first figure and this piece 1' from the second figure, show me or explain to me why those two guys would be congruent. So that would be a situation of the proof part. Now, for the Hilbert construction part, maybe it's something as like a fill-in-the-blank construction. Maybe it would be something where it says, hey, this is the Hilbert construction that we think goes with this dissection. Do you think it works? Or explain where this person went wrong, type thing. Now, in terms of things to look out for, and this also gives you an idea of the level of difficulty that you might see with dissections, not much more difficult than what we saw when we were talking together. So the first two are what we talked about, where you're given some diagram and you want to see if it verifies. And classic examples of those are from, I pulled it, exercises 24.5 and 6. The next 3 here are all very, very similar. This one here says you start off with a triangle and you dissect it into a parallelogram. We did that one together. But maybe you're given a triangle and you're asked to dissect it into a rectangle. So, maybe you're given a parallelogram and asked to dissect it into a rectangle. Maybe you're given a rectangle and you're asked to dissect it into another rectangle. And then the last one, which is a little bit different. This one is actually a tie-in between dissections and area. So this exercise right here is really trying to get you to say, use some sort of dissection to be able to find the area of a regular polygon. What would you do? You cut your polygon up into a bunch of different little isosceles triangles where the base of the triangle is the side of the polygon, and then the other vertex is the center. That means they're all congruent isosceles triangles. find the area of that one isosceles triangle, multiply it by the number of triangles you have. Bam, you found the area of your polygon by way of a dissection, roughly speaking. So that might be some sort of way of combining these guys together. And notice that feels more like something you would have done in the past too. Because yes, you guys have totally done this stuff in the past, just maybe not at this level, and definitely not with these terms, unless you've taken the course before. So that would be dealing with dissections of various types that you could see. And then the last topic we've got here is dealing with constructible numbers, and we saw constructible numbers in two places, in section 13 and in section 28. And in section 13, this one is the one where we have the definition of what a constructible number was. And remember, that's when you have some number, and it can be built from a bunch of fractions, as many or as few as you want. And on those fractions, you can only add, subtract, multiply, divide, and taking a square root. So there's no imaginary numbers involved here. There's no third roots involved here. There's no pi's involved here. It's just the basic operations. So you might be asked to actually, with a straight edge and compass, construct a number. You guys had an activity to upload a while back that talked about that one in conjunction with section 13, I believe. Maybe you need to construct a square root. There's a bunch of different ways to do that one. Everywhere from building a bunch of triangles to dealing with a circle. Depends on what you have in your Hilbert plane. Maybe you're asked to find a trig function, either sine or cosine of some angle. In this case, you'd need to be able to apply trig identities. I'm not assuming that you know all your trig identities. I would provide a list of the ones that are the best to use, and then you select which one you want. And if you want some examples of these of those type of things, these are some exercises in section 13 that talk about that. And the other thing you'd have to know is all of your answers would be expected to be in standard form, or they would be given and you'd select which one of those guys would work, something along those lines. And then the last thing that we did with constructible numbers was, I believe it was actually on Wednesday, feels so long ago now, in section 28 right here. This is where we had some algebra tie-in, and we looked at making a chain of fields where we built up to the number we cared about, that constructible number. And we also looked at what this thing of the degree of Q adjoin potential constructible number brought out by Q meant. And remember, that was the thing that was simply the dimension of our vector space when we considered our field as a vector space. Okay. So in terms of individual topics, that would be the idea. Before you completely freak out, because this is where everybody freaks out, there is absolutely, positively no way that you could possibly do this test with all those topics. It's just not going to happen. It doesn't happen on paper version. It's definitely not going to happen. I don't want to type up all that stuff. So typically what I tell people is, depending on what these questions are, you're only going to get some of them. So for example, the dissection question. If it's something as simple as, does the dissection exist between these two figures, and all you have to do is find the area of the two figures and show that it's the same or not, you might get one of those guys regardless. If it's the more complicated ones down here that actually gets in the full-on dissection of the two figures, that's where you're not necessarily going to have this question in conjunction with something like a configuration question that's also a time eater. This one, both time eaters if you have the full-on question. Now with a configuration, if you have something that's only part of it, where it says, hey, I'm going to give you these points, you figure out the coordinates of these points, and then figure out the equation of these lines, and maybe that's all it asks you to do. It doesn't ask you to do the full problem. Maybe in that case, you actually would get these guys together. Otherwise, typically I give people either configurations or dissections. So depending how I write up these problems would depend on how much of them you would get. On a paper test where you would have the complete problems, you can only have one or the other. For us, where you might only get partial, like a step 1 or a step 2 of what the problem would be, this is where you might actually get something of both the topics. Right? But that's the only way it would happen. Area can also be a little bit of a time eater, but it's mainly because people forget where to go. So if I walk you through it in terms of a bunch of fill in the blanks, probably wouldn't be as much of a time eater. And constructible numbers typically only mess with people if you forget how to do either algebra or how to deal with trig functions. So I would definitely recommend boning up on that if it's been a while. So that's it in terms of these guys. Roughly speaking, you could break constructible numbers up into a couple of different places, but roughly speaking, 4 topics, or if you want to break this one up, 4 to 7 topics. Now, in terms of the proof questions, there's going to be 1 to 2 proof questions, specifically topic proof questions, and they'll be pulled from this list or from something very similar to this. Okay? And you'll notice that they come from a variety of topics. The first one up here deals with a configuration question. That's Pappus's theorem. This guy right here. Bubbles everywhere. Okay? Then down here in exercise, wow, that did not do very well. Do not have the fine motor skills anymore for that. That is really sad. Down there in exercise 23.2, this is one that dealt with area, that said, hey, we've got 2 squares that have the same area, show that they have congruent sides, and we had to build what the formula for the area of a square was. Then theorem 28.3, we did the outline of this guy in class, doubling a cube. We showed that it didn't work and we needed the stuff with the fields in order to do that. These last 3 guys are all dealing with non-Euclidean geometry, and the 2 examples I've got prepped up for us as soon as we stop talking about the final exam are going to be really similar to those guys. So I get some extra tie in there for you. And the remaining 3 guys that I haven't talked about yet are sort of combo questions. So this first one, 20.3, this guy really just deals with similar triangles. You find the appropriate theorem, it's almost immediate. This one here, which is exercise 20.8, it also was back in exercise 14.2. One of them deals with similar triangles, and the other one deals with configurations. It's 2 different ways to show the same thing, and that would have been homework, last homework set of showing that you have the parallel lines when it looks like a bunch of little triangles inside of an angle. You can do that with configurations where you go in and you find all the vertices, all the coordinates of all the points, you find the equations of all the lines, and if you want 2 lines to be parallel, their slopes have to be the same. Depending on how you think about it, that may actually be easier for you to think about, although honestly there is a theorem that just almost directly tells you it as well with similar triangles. And this last one right here, I don't know why it was in similar triangles. It really is a configuration question that says, how can we know that we have some equilateral triangle exist? And this is actually a very, very simple configuration question where you find the coordinates of the three vertices, and one of them has to have a square root in it, and you say, oh yeah, that's the square root that I need for this equilateral triangle to exist. Okay? So that's sort of the outline, and this spans roughly the topics. There's no way you're going to deal with all of these guys. Some of them have been homework questions, some of them we've done together, and a couple of them are brand new. You're probably going to get 1 to 2 of these guys, and they're probably not going to be from the same topics. So for example, if you get 1 proof question on non-Euclidean geometry stuff, your second one isn't going to be another non-Euclidean. It would probably be back up here. So that would be the idea behind the final exam.